Okay. Right. So we are going to look at the Q. So we're going to consider the shear stress at point B, E. And we know it's box beam because it's 2Q. Right, box beam analysis. 2Q. Right. Again, the most important one is the Q at point E. Okay. So it is the width will be 20 because the thickness is 2 millimeters, right? So this is dead center. So the width is 20. The depth is 2, right? And the Y bar is 25. Right, we're going to take the Y bar 25. So this will be equal to 20. So it's going to 1,000 millimeter cube, or 1,000 times 10 to the power minus 6 meter cube. Right. So the shear at point E. So the force that is given is equal to 5 kilonewton. Okay, so 5 times 10 to the power 3. The Q is 1,000 times 10 to the power minus 6. Right. The I is 133.75 times 10 to the power minus 9. 2Q, the thickness is 0.002. Right, the thickness is 0.002. Okay, so 5 power 3 times by 1,000 power minus 6 divided by 133.75 power minus 9 divided by 2 divided by 0.02 is equal to 9.345. Okay, so ours at point E. So we start from point E first. Okay, so it's about the same. Okay. Okay, so they had 500. Don't do what they do. Okay, do what I teach you. Okay, so this is 9.35. Okay, they got 500 is as good as we couple this together. Okay, we bring these two together. That's why it's 500. Okay, but don't do that. Okay, follow what I teach you. Okay, now the shear stress at point D. I'm going to do both. Okay, we are going to find from the top and from the bottom. Okay, so we're going to do the shear stress at point D. Right, and this is also box beam. So I'm going to do the top. Okay, so I'm going to call this the top and then the bottom. Okay, top, bottom. So at point D, right? So we are going to look at the top section. Right, so this is going to be box beam analysis. Again, 2Q. Right, so now the area we have to consider is not just the yellow, is also, can you see the part I'm shading? No, you can't see at all. So we are also going to look at this part. Okay. Okay, now we're also going to look at that part. So from there, so we are going to look at Q at point D is equal to Q at point E, right, plus by twice, the width is 2 millimeters. The depth is going to be so this here to here is 25. So here is 1 millimeter, right? Because all these are taken at the center. So this is 1 millimeter. This is 25. So it's going to be 26, right? And then the Y bar, right? The y bar will be, wait, the y bar will be 2 point, hold on. The y bar, so from here will be at 25. Okay, because of the center, 25. Okay, so Q at point E will be equal to 1,000 plus by 25 times 26 times 2 times 2. Okay, so the width, so it's 26, 100. Wait, 2 times 2 times 26 times 20. What am I doing? It's not 25, it's 25 divided by 2. It's y bar. Hey, 25 divided by 2 times 26 times 2. It's got 130. So 2 times 2 times 26 times by 25 divided by 2. Sorry, it's not 25. It has to be 26 because you have to take the entire length and divide by 2. So 26 times 26 divided by 2 times 2 times 2 is equal to 1352. So 1,000 plus 1352 is equal to 2352 millimeter cube, or 2352 times 10 to the power minus 6 meter cube. Okay, so that is our point D. So the shear stress at point D, right? So this will be equal to 5 times 10 to the power 3 times by 2352 times 10 to the power minus 6. And then we're going to divide by 133.75 times 10 to the power minus 9. And then twice, because 2Q, 0.002. Right? So 5 power 3 times by 2352. 5 power 3 times by 2352 power minus 6 divided by 133.75 power minus 9 divided by 2 by 00. So the answer is A. I got weird number. 5 power 3 times by 2352 power minus 6 divided by 133.75 power minus 9 divided by 2 divided by 0.002. It's equal to 21.98. Okay, so it's 21.98. Okay, 98. I get 981 times 10 to the power 6 Pascal. Let me do it again. I'm not happy with numbers. 5 power 2 point. 2 point. Wait. So sorry. This should be minus 9. Okay, I do apologize. No wonder my number comes out funny. Okay, so let me try it again. 5 power 3 times 2, 352 power minus 9 divided by 133.75 power minus 9 divided by 2 divided by 0.02. That's much better. Okay, so if you look at their point D, they have it at 22. We are not that far away. Their Q is 1.176. So if you take 2352 like what we have, if you take 2352 and then you divide by 2, okay, it's 1176 exactly like what they have. Okay, but when they get 1176, they have this minus thing that is going on. Don't bother. Okay, and like what I told you guys. Okay, do how I teach you and you'll be fine. Okay, now the thing is this. That is from the top. What if now, okay, what if now we look at stress at point D, okay, and then we look at the bottom section. Okay, and the bottom section is also box beam. And is hold on, it is no, it's not in fact, if you look at the bottom, right, if you look at the bottom, right, it is not, is it a yeah, it is not a box beam. Okay, it is a white flange because you only have one Q. right? It is a white flange, yes or no, right? So it's not the same anymore. Okay, it's not the same. So you it's a white flange section. Okay, if you look at the bottom, so it's Q. Okay, because your Q is only flowing in one way at the bottom, yes or no, right? It's not, the Q has not been split up. Okay, so how do you find, okay, how do you find the how do you find the first moment of area now? Okay, so is it, okay, now the question is this: is it, are we going to take this entire area? Okay, are we going to take this entire area? Okay, are we going to take this entire area? Right? So the thing is, if mathematically is correct, okay, whether you take it from the top or from the bottom, the numbers should be the what? The numbers should be the same. I repeat again, whether you take from the top or the bottom, the answer should be the what? Should be the same. Okay. So now, if we take the whole green section, you and I know, right? The first moment of area will not be the same between the top. So let's look at Q, right? At point D, right? I'm going to put in a green highlight. Okay, I'm going to put in the green highlight. So this will be equal to twice, right? So this is the two webs, right? We have two webs. The width is 2 multiplied by 26, right? That's the depth. 26 divided by 2, that's the y bar. Okay, plus, okay, so plus the bottom part, the width is what? 8, right? And then the depth, the width is 8, the depth is 2, and then the y bar is 25. So this is the lower flange, right? So when you add this up, okay, so 2 times 2 times 26 times by 13, so it's 1352 plus 8 times 2 times 25 is equal to 400. So this is equal to 1352 plus by 400 is equal to 1752 millimeter cube, right? So now, if we were to, 1752 is not relatable, right? Cannot relate to what? 2352, right? It can't. So the valid answer, okay, the valid answer should be equal to 2352 divided by 2 is equal to 2352 divided by 2 should be 1176. And this is wrong, right? 1752. Why 1176 is correct? Because at the bottom we only consider Q. At the top we consider what? 2Q. So what I did, I just divide them by 2. So we realize like taking the whole green section is not right. Why is it not right? Okay, it's because when we did all the rules, rule 1 to 5 now, okay, remember when we did all the rules, this is our Vy, right? This is our Y max, right? And then we have our variable Y, right? So remember we had this shading, then we have this Y bar, then we set the rules. Now, when we derive this, an important thing, a really important thing to take note is this. Q is only in one direction. right? Whether at the top or at the bottom, Q is only what? At one section. So for this case over here, we have a reverse flow, right? Over here is coming down, over here is going up. We cannot have this reverse flow. So what is the right area? Okay, what is the right area? Right? So remember, what did I say? We cannot have reverse flow. I repeat again, we can have a change in flow direction from vertical to horizontal, but we cannot have the two vertical flow change direction. So now, what if now we take this area? Okay, what if now we just consider this area? Okay, we just consider this area. There's no, we just consider the L. Okay, will the value be the same? Okay, we try. Okay, so consider QD. Just consider the blue section. Right. So now we look at this. Right. So the width. So for the blue section, the width is 2. Right. This is 26 by 13. Now this is for the web plus lower flange. So the lower flange I'm going to take is going to be 10, right? And then the depth 2, and then we're going to multiply by 25, right? So if the answer is correct, it should be what? 1167. So 2 times by 26 times 13, so it's 676 plus by 10 times 2 times 25, 500. Okay, so 500 plus a 676 is equal to 1176. All right. So we set up another new rule, right? The flow, right? The flow, the Q, do not consider the Q in reverse flow. This is our rule number what? Our rule number 6. Okay. Why? Because mathematically, this is how we derive. Okay, this is like week 4, right? We derive this on week 4, and for that reason, right, we cannot consider the reverse flow. I will continue this problem again on our next lecture. If that's the case, have a great weekend. Okay, don't be too stressed. And next week we're going to have a lecture again. Okay, okay. Then if that's the case, I'll end the tutorial. Thank you.